All right, is it start time yet, or we have a little bit of time, or do I need to wait, or do I need to go?
2 minutes.
Okay, cool. Well, might as well use that chance to see who's here. I work for USC, Southern California, not South Carolina. I just wonder kind of like what kind of people, how many people here are kind of like, would you say, are in academia? Okay. How many people in game space, strictly game space? Okay. How many people here into simulation space, medical simulation space, so other types of things? And how many people into kind of general education? Okay. All right, cool. And how many people here program things themselves? Okay. How many people build content but don't necessarily program it? Okay, so you're doers. Okay, that's good to know about. Oh, hi, how are you doing? So I guess we're going to start in 1 minute.
Sorry. I think that's loud.
Okay, thanks, man. So I'm glad I wasn't the only presenter wearing shorts today.
Yeah. It's been too hot lately.
Yeah, I'm on some panel tomorrow, and I said I'm going to save my pants for that. So I figured that I can only wear them so long before getting dirty, and I brought one pair. So I'm Thomas Talbot. I'm from the USC Institute for Creative Technologies. I'm a physician. I'm a pediatrician. I had a 12-year career in the Army. I was in charge of an R&D program for the military for developing serious games for a number of years. I've written my own games. Getting into this, I started down a pathway that involved an element of conversations and virtual human conversations, and then it evolved into kind of conversation games, or you could call them conversation simulations. So I'm going to start very early in the process on this, and if there are questions, feel free to chime in, okay? I think we'll get started. I have a few things to show, and we'll see. So let's start. Oh, by the way, there was Serious Games Montreal. I gave the same presentation, hence the French on the screen. So I figured they liked that there. So okay, so this is myself. I started. This is I think me in 7th grade, and we were not allowed. They were told you're not allowed to play games on the computers at school. But someone would say, "What if we wrote our own game?" Oh, then you could play it. So we all wrote our own games, and some were better than others, but that was a great inspiration for many of us. So, like I said, I was in the military as a physician. I like kids, I like adults, I like everybody. But I had a lot of fun doing that. And then I got into writing my own simulations for various things. And had a lot of fun with that. And learned a lot throughout the process. And the big thing that I am about is doing things that work, doing things that have a useful purpose, often that can be measured, I like doing things that are neat, but I want something that's neat to actually have a function. And sometimes you could do something very simple that has a powerful function. It doesn't always have to be something complex. So I would like to start us here with a text adventure. And I think, how many people have here played text adventures? Actually, quite a few. What I think, if you actually play a text adventure, and you can do a search online, and there's some online playable versions of these old ones, you'll be surprised at how they can really stimulate the imagination. I mean, and there's not even a lot of technology going. Mostly you're exploring, and you open things and look at things and perform actions, and you have a simple parser there. So in Zork, you are standing in an open field west of a White House with a boarded front door. They didn't need that comma there. There's a small mailbox here. Those words create a whole setting and a picture in your mind, which I think is really cool. And I think a lot of times in games we want to show things explicitly, but neglect what leaving things to the imagination can do. And these simple words that sometimes were played over a teletype or an old text monitor, they can convey these things. Now, when you provide a cursor and a space where people can type things in, You can never predict what people will do or everything that they will do. That's one problem in this space. For example, what do you, I mean, of course someone's going to do something like that, right? And we can't account for all possibilities. Okay. And then, I don't know, this is another one where you have various options, you can type things. But storytelling goes a long way to conveying things in people's imaginations and their expectations. Now, if we move forward another 10 years from the 70s, and we look at a game like Ultima 3 Exodus, which I spent a lot of time playing as a kid, you would go through this big world where you can scroll through and have all these great adventures, and there were characters you could talk to. And the level of interaction was talk. And you can type the command talk more than once, and sometimes you get information out of the characters. I remember when I was doing it and there was a kid in the castle and I said, talk. And he was like, oh, gee, are you an adventurer? Talk again. Oh, mister, that must be really neat. Can I touch your sword? Oh, and you go on. And eventually, if you did this enough times, you realize you're completely wasting your time talking to the kid in the castle. But I did it. And it was a very thin interaction for that part. Now, if we go forward to the late 80s and to the early 90s, we had graphical text adventures. This is King's Quest by Sierra Online. And actually, it's weird, they had the name Sierra Online before there was an online very much. And you could move this character around, but some interactions required you to type in commands and things as well. And these were very, very popular family games at the time. There's a whole series of them. Then we go forward, let's say to 2010, and World of Warcraft. Now, even though we have a very reasonably rich multiplayer online text adventure, we have chat, we still have a command prompt. Now that's mostly used for various configuration commands and text chat with other players. But it's still there. So we haven't really moved too much in 30 or 40 years of games. We still have it there in some of the games. Now, look, have we really advanced in how we interact with virtual characters? Oh, look, exclamation point. Click on it. It's not any different than Ultima 3. Here's your quest. What would the possible adventure category in talking with this character say, hey, do you have stuff to say? Or, what's going on? Well, and they could feel you out a little bit and see if you're worthy of getting a quest, or maybe you get like a quest that's almost certain to send you your death, or a good quest, or an easy one, or maybe you'll get ripped off. I mean, there are a lot of rich potentials in these non-player characters that we are currently not taking advantage of in mini games. But there's the potential there. Instead, we have an exclamation point or a question mark, and we have a box of text. No real difference. Now, something else has changed in games, though. Now, some of those mechanics haven't changed, but when you look at major gaming titles, some things have. Does anybody recognize this game? Grand Theft Auto, like 2, right? This game is delightful. You go in, you beat up people, you steal cars, and you drive around crashing into other cars. I mean, what could be more fun than that? It's obviously the naughty fantasy that is just delightful to explore. And I remember playing this, I think, on my nephew's Dreamcast or one of those consoles at the time, Nintendo 64, I don't know what it was. But I remember picking that up and just having a delightful time and cackling while playing this game. Now, Grand Theft Auto, Grand Theft Auto 6 is the one coming out now. There was a change in 3 than 4. And that change was that just having one quest after another, driving around wasn't enough. And they realized fitting a game and missions into a story arc has a great utility in capturing the user. So what they started to do in Grand Theft Auto 3 and 4 was they'd have a plot and a storyline. And there were characters. When you finished certain quests, you would have these characters talking, and you'd be part of a mobster drama or something like that. Although the level of interaction in those counters was 0, you still had that. So you had drama. You got to know your character. It wasn't just the little guy on the screen. It wasn't just, Mario and Luigi. This guy has a personality. He interacts with people. Some of the guys he works with don't like him. Some do. Some are skeptical. And that creates a whole new rich world for games. And then we see some of those interactions here. But they're basically just played for us. So what I do is I do simulations that involve conversational elements. I don't do just that, but I do a lot of that. And so here are some examples. So here is a trainer that's designed for autistic young adults to practice their job interview skills. And that really worked. It really greatly improved the successes of the probability of getting a job for a young autistic person. That was funded by the Dan Marino Foundation, and it was worked by my colleague Skip Rizzo. Here is a virtual patient, which I'll show you. Oh, I have some videos. They're kind of older, but I got videos of that on this presentation. Here's a virtual patient you can practice your medical interviewing skills with. Here's something made by these other guys at a company called Cognito, where they have interpersonal behavioral scenarios playing out on the screen here between the characters, and then you choose various interventions or what you want the characters to say. And you put yourself in different characters' places. And these are really cool. I'm kind of focused a bit away from entertainment titles at this point because I do practical type games, not just really entertainment titles. But there's a lot of potential for these approaches here. And often we're used to entertainment game technology informing what we can do in simulations and serious games. In this instance, it's going the other direction. Things we do in high fidelity simulations will eventually make its way to entertainment titles, I believe. So there are different approaches to talking with characters. And I will go through these with you because I think it's good for you to know about these things and kind of see what they look like a little bit. So we'll go through a language parser, which we already showed, simple, responsive, interactive, choice-based dialogue, as well as AI-based, like natural language processing type dialogue. So I think one of the first applications that gave the appearance of a conversation would be Eliza, which is a virtual Rogerian psychotherapist. And all it really did was take things that ask you a few setup questions, then it parses little words out and puts your own statements back at you as questions. And I think it's pretty thin, but some people will spend 15, 20 minutes on this thing, typing things in and thinking they're having a conversation. They're not. But it was kind of a neat experiment from 1966. And it's simply parsing language and knowing certain parts of a sentence and then presenting questions back to you. And you can see some examples of what that looks like there. And you can run this online. You can just type Eliza. Now, we talked about clicking on a character and getting a simple response. That's true whether it's Ultima or it's a lot of the newer games. Now, I like when we look at conversations. This is my simulator called USC Standard Patient. We do a lot of training with the military and with others where we provide specific choices of dialogue, and we talk with a virtual human character. And I like that a lot because there's a lot you can do with it. I'll show you some examples of simple to more complex examples of what you can do with it. And there should be audio. It's not very... Hold on.
You are concerned about vaccinating Rhonda. What are you worried about specifically?
My husband and I are worried about the connection between vaccines and autism. We heard about it on Dr. Oz. It is really concerning.
Stories on television like this are worrying a lot of parents. I can see why you'd be concerned.
I do not want to do anything to hurt Rhonda.
As a medical doctor, I have spent quite a bit of time looking at this issue.
I see.
Okay, so that was a type of structured encounter where they're talking about someone with vaccine hesitancy. And she's choosing choices. In this example, she's speaking them. Actually, you can speak the choices out loud. And even if you don't say it exactly, the system will interpret. Although at the time we recorded that video, you clicked on the choices and you couldn't talk to it. And we just did that to make it show well. but you can talk to it now. So it's real. But here's another example of a structured encounter. And this is one that actually someone who just did a workshop on how to make these that I held at International Meeting Simulation Healthcare made. And the funny thing is, I have 5 kids, this is a common situation, and the avatar in this one is actually one of my kids. I had them make one of my sons and one of my daughters. My daughter, I only have one daughter, I have 4 sons. I actually had avatars made of them. And so this is a common household scenario here.
You go to have a snack and can't find the Doritos.
Hey, Dad. What's going on?
Do you know what happened to the Doritos?
I'm not sure. Maybe someone ate them.
Do you know who would have done that?
Maybe it was Alex or Brenda.
Did you see or hear either of them snacking?
Brenda was saying she was hungry a bit ago, and then hurried out of here.
But your fingers smell like cool ranch.
I'm sorry, I didn't mean to finish them off.
That's okay. Thanks for telling the truth. Let's go to the store together.
All right, so
We found the culprit. Good job. Frito-Lays would be proud of you.
we couple that with a rich assessment. Some of the things that we've changed since I recorded that video is we made it very flexible, so you don't have to say the exact choice. Like, you can be fairly approximate, and it'll get you to the choice. Another thing we did is we have an emoji and a color flash on the screen to see if you gave a good response, a mixed one, yellow or red, a poor response, or a happy, middle, or sad face. That's optional. And we also couple that with an assessment. Probably a real scenario, I wouldn't, you don't have the ability to smell his fingers. It was just kind of funny. But that gives you an idea that you definitely have an outcome. Like, even in this short simulation, you can find the culprit, you can miss who the culprit is. Or with the vaccine mother, she will vaccinate the child today, she will absolutely refuse because you're such a jerk, or maybe she'll think about it at a future visit. So you have 3 potential outcomes. So let's go inside some of these conversations and take a look here.
Go to have a snack.
So here's what the feedback looks like from one of these encounters. And I think this is kind of like a suicide. No, this is an opioid scenario. So here we show your outcome, which was a good outcome. Then we said your quality, you made this many green choices, this many yellow, this many red. And then we look at specific metrics we're measuring, like you gave 2 judgmental responses, or you provided empathetic responses out of 2/3 of the opportunities. And then we go through your transcript and say, why do you think you needed so much more medicine? And this is a poor choice. I think you might have an addiction. We can click on that and see what the other choices were and how they'd be rated. And also, they said that this is blaming the patient, and that's feedback from the scenario author. So you're able to go through that. So that's why I like structured choice-based approaches, because every choice they make is a fulcrum for assessment. And they have to declare what they're doing. Now, if we go back, this is the hesitant mother on the vaccination scenario. And here you go, she states a concern. I think you say something being a jerk, she's kind of unhappy with that, but you see there's a green, yellow, and red line here. That indicates how the response will be evaluated. And then you go through several things in a row, and then based on what you say here, you can converse more, or she really has made up her mind, you're an idiot. And then these logic nodes evaluate other variables that are set up, whether you show concern, or seem scientific, encourage her, or defensive. So it weighs these various variables to decide whether she's going to get the vaccine, think about it, or no vaccine. And everything we build uses text. So as a medical doctor, this is the choice, and she says, oh, I see, when you get into that, and then you have a chance to see some choices. And so you can say, science has shown blah, blah, blah. We now know that blah, blah, blah. You really shouldn't. And you see, and this is a good doctor saying, I've got some expertise. I've looked at this issue. And then you go on to the next thing. So that's how something like that would look. But you'd see there's 1 entrance and 3 outcomes on the right. Okay, so let's look at conversation design patterns. And by the way, what's cool about choice-based dialogue systems is some things may require some cool code and things, but you can do this pretty easily yourselves. You can record video, right, and edit it into clips, and you can use something like an HTML or Visual Basic or an app developer tool, an Android or iPhone, or you can use PowerPoint. PowerPoint has a thing where you can press buttons to go to a certain slide and just throw a video on that slide. So you can't do the higher level functionality, but you can do the basic level of functionality of these conversations with the tools already on your computers and devices. So here is the ultimate kid in the castle. And you say, talk. Oh, are you an adventurer? Oh, that's a cool sword. Oh, can I touch it? Go back to the beginning. Pretty simple. But at least, instead of a paragraph, there's at least a couple steps you go through. So, oh, you're an adventurer. Oh, you're looking for a quest. Oh, I know a good quest. So there's, even linear, there's use for a linear dialogue tree. I guess that would be a trunk, not a tree, right? Okay. All right, so here is, and by the way, anybody know StarCraft or play StarCraft? Okay, good. All the other examples are StarCraft themed. So in this example, you're talking with a character theoretically, and someone says, I'm sure Emperor Minsk has been hard on your planet too. And you're Jim Raynor, and you go, you know. So your choice is, we love Emperor Minsk. That's like your North Korean response. Yeah, Kim Jong-un is our great fearless leader, you know. Oh, he's not popular on our planet, but blah, blah, blah. Or yes, we definitely want to overthrow him. Now, maybe this guy's a spy, so if you say the bad choice, you're a traitor. Ah, I see you're a traitor, and you get arrested. And then you say this one, but he says he's not sure about you because it's a medium answer. And then here you show your loyalty, so you fit right in. You know, oh yeah, I know what you mean. I didn't really mean that either. You're a good guy, you know. Let Emperor Minsk keep doing what he's doing. So that is a simple single branch. Now the truth is you can't get much dynamism out of one branch. But let's see what we can do to make it more interesting. Let's add some judgment. So here you have this node. Now probably you wouldn't have one node. You would probably have like a conversation of 5 or 6 nodes. So you kind of go, what do you think of Emperor Minsk? Oh yeah, what do you think what's going on Arcturus Prime? Wasn't that a cool place? Oh yeah, I go to vacation there. The Zergs are a problem though, you know? And then you have your conversation, right? And then along the way, it looks at the quality of your choices, and then maybe some of the choices are associated with certain variables, like how loyal you are to Emperor Minsk or likelihood to be a revolutionary, right? And then based on some measurement coming out of this last choice, right? I can say, yes, let's overthrow him. That'll definitely make me a traitor no matter what I did before, right? Now, if we're chatting, oh yes, he's the best. He could say, do I trust him based on his prior statements? When he said this good thing to have him fit in, or maybe I'm not sure about him. Or if I said an indeterminate response, I could say, well, is he okay guy, or do I really think he's this, you know, disloyal? And I could put him in the unsure or get him arrested pile. And that could be his outcome. Then, and here's an example of that. Here's the example of we go through several. Let's talk about Emperor Minsk. Let's talk about Zergs. Let's talk about Ghosts. Let's talk about Antigua Prime. And then the guy goes, do I like this guy? Do I trust him? Does he seem loyal? And depending on that, you either fit in, unsure, arrested. And basically, almost all my simulations, no matter what their structure, they kind of end that way. All right, I want to show you another design pattern. This is called an unlocker. And an unlocker is basically choices where, depending on your choice, it opens up more avenue of conversation or less avenue of conversation. This example was used at the Gould School of Law at USC, and it was meant to be a measurement tool for forensic interviewing of children. And the interview is talking about a birthday party. And what they train people to do is not ask very specific questions like, what happened, what did you do? Or is it that? Yes or no, and like which, where, very specific questions, sometimes lead witnesses. So then they want very open-ended questions. So what happened? And then what happened? And what else? And what did you see? You know, so they're looking for very open-ended questions. And so the simulation was designed, if you ask open-ended questions, you get longer responses from the character, the child here, and it opens up other topics to talk about. Whereas if you ask very specific ones, it won't open up new topics, and you'll have a shorter interview, and the responses will be yeah or yes, or something like that. So let's have you take a look at this example. There's all clicking, so you have to read what's on the screen. Whoops. Let's try this again. So here's your choices. Like, tell me who came to your birthday, or did you have a birthday? You click. Tell me everything that happened on your birthday.
When I came over, we had a party and we played games.
So 3 topics got unlocked. Let's click on friends. Who came over? Did your best friend come over?
Jim, Maddie, and my cousins came to my party to play games.
That was a bad choice.
We had chocolate cake.
What did you do better than did you have strawberry cake? Talk about the cake. It's a new topic that unlocked.
My mom carried out a big chocolate cake and it had Spider-Man on it. Spider-Man. We went in a jumper and we hit a pinata in the backyard. We had to take off our shoes. I did flips and I played basketball. I ran into my sister and she cried.
All right, so you get the point.
Yeah.
So let's go towards the end here. So then we have this. Now look at, this was a debugging screen meant for us, not for the subjects. But when they took the test, they got to see the screen, and we did not remove it. It was intended to have been removed. By the way, you notice the character's low res? We find that having super high fidelity characters is not important, and having super high fidelity characters actually makes them more difficult for users to accept them. So we actually keep the fidelity moderate or low, although we do like to express things visually through nonverbal expressions. And then something to increase our kind of emotional transfer is, notice that we used a voiceover actor, not a synthetic voice. I tend to build everything with synthetic voices, but if I have something where conveying emotions critical, I will do a voiceover actor after building it with a synthetic voice. But the cost of that is you can't change it. Remember that. And I've seen people where a year later they get the same person and it never sounds the same, even if it's the same voice actor. So if you expect to make any changes, you'll have to redo all your voice responses. And it's expensive, and it's had to been done many times. Fortunately, not by me. So here we have open-ended questions like who, how, what questions, yes, no questions. And the average words elicited for response from the child, and open-ended questions elicit longer responses. Average word count of 5 or more is good. You unlock 6 to 7 categories. By the way, it enters the conversation at a different place each time you run it. So you really don't memorize the responses so much. So they saw this, and 30-something% of the responders, the people who took it as a test, retook it because they saw this and wanted to perform better. And they did. Statistically significant results. They actually, not only did they perform better when redoing it, but they adopted a different strategy to their questioning. They realized, the game is get more words elicited and unlock responses, and I do open-ended questions to unlock the response. They realized what the game is, then they went through and asked all open-ended questions and had a wonderful interview. So we've actually published that, and it's kind of weird because it was never intended to test any learning gains. It was just meant to be an evaluation. So I thought that was kind of cool. So that's what an unlocker basically means. Some variable triggers along the way that unlocks a new branch of conversation. And that's all that is. Now, any questions before I move on about structured and choice-based conversations? Oh, one other thing we're doing now is that some people don't like these, because we show them the natural language, the random access ones, and they say, oh, that's really cool in Star Trek, I want that. And I'll say, well, pedagogically, you want to give them choices. And we face that a lot. So one thing that we are doing is taking choice-based conversations and then having things where you can say whatever you want. Like, you go through some choices, and then you go, confront her about her opioid use. And there's no choices. Although we have a help button. If you press it twice, you get a hint the first time. The second time, it'll show you choices. But yeah, then you have to say, well, gee. So, okay, no questions about, yeah, there is a question, yes.
So you're making branching dialogue and your players replay it and they go through it again. How do you keep things feeling new when they stumble into a branch that might have some repeat? So like, let's say it's, you went to a party, what did you have? Cake. You want to get to the next part. How can you make that so that they don't start tuning it out?
Okay, a couple things they do. First of all, we discourage use of closed captioning, unless you're having a hearing problem, because it actually changes it changes the experience to be able to see what they're saying, and people try to skip through and read things really quickly. So we force them to listen. That's the first strategy. The second thing is we want them to repeat part of these experiences. We want them to go through it again because we're modeling behaviors we want them to follow. So there is an element of repetition to these, because we're not doing this for entertainment, we're doing this for training usually, or at least I do. So for some of these conversation elements, I expect them to go through the same thing. And I want them to go through the same thing because I want them to get used to the responses they should be making. Now, it is possible that you may skip some laborious parts if you perform well earlier in a conversation. You may skip some element you don't need to otherwise. And that would be a strategy to alleviate your concern. But I'm not going to expect them to play this many, many times over, 20, 30 times. I mean, they may do this 3 times or 4 times to get the training points I want. And that's probably the maximum number of replays we're going to get. So we can tolerate having some repetition, and then sometimes we want the repetition. It's because we're reinforcing the types of responses they should be giving. Good, that's a good question. Okay, so another type of conversation format I call natural language random access. And I abbreviate that as an NLRA. Natural language random access means you could say what you want to the computer. Now, we know that computers really aren't capable of doing this on general topics. So how do we allow an artificial intelligence system to handle it? Well, there's 2 ways. You can have an in-depth conversation in a very narrow area, or you can have a little bit broader area if it's shallow. Right? So if you look like an assistant, like a personal assistant, like Siri, Cortana, or Alexa, they're very shallow. They're basically command parsers. Then they have an NLU system to figure some other things out once they've figured out the root command and the word. And they're broad but shallow, and then they open up another pattern. So the other constraint you have is initiative. With a choice-based conversation, I can have the virtual character take control of the conversation sometimes. I can have the human take control. But with virtual ones, it's generally the AI characters in control or the humans in control. Mixing initiative can be done, but it's difficult. It's really difficult to do. So generally, these are mostly one-way interactions with a response or questioning. Although you can blend these, it requires work and it requires experts. So constrain the domain, narrower improves your performance, constrain initiative, and constrain scope. That gives you performance. And these things are probabilistic, not deterministic. So for example, while it's true in the choice-based interactions that not every choice directly leads to the same outcome, because you could put logic in that says based on a whole bunch of choices they made, let's go here rather than there, and that helps with replay. Here it's probabilistic. So if someone's asking about Emperor Mensk, you have to give it training language data and things like that, and hopefully it will figure out you're asking about Emperor Mensk and not about someone else. So there's never a 100% guarantee you're going to get the responses you're looking for out of a system like this. It's probabilistic. So here's an old demo from 2015 of a virtual patient.
Hello, doctor. I'm Dr. Cole. Nice to meet you. Nice to meet you, too. What brings you in today? My ear really hurts. That's why I'm here. Tell me more. Well, it started about 3 days ago and was just irritating. At first I thought it would pass on its own, but the ear pain just kept increasing. That's when I started taking Martran. It's getting hard to sleep now because the left side of my face is starting to hurt too from it.
So she's telling a story, and he's letting her go on.
I'm sorry to hear that. Thanks, doctor. I appreciate that.
Let's try some specific questions.
Have you tried cutting down on your drinking?
I tried to stop drinking in the morning. Now, I won't have my first drink before 11.
Do you have blackouts when you drink?
Yes, I can never remember the night before.
All right, so in these examples, we've done a lot since I recorded this video, but it's basically the same. So we tested, for example, that girl with medical students back in 2015, and we got appropriate responses from the system 92% of the time. So 8% of the time, something weird came back. All right, we realized that we could have corrected about half of those through better training of the system and things like that. I think the theoretical maximum, because you can is about 95% for a system like that. Prior to this, the best was like 76% to 80, and that's a big difference. You kind of want about 88% or better for people to be comfortable with the interaction, and below that, people don't tolerate the interaction. I will say that, so we have really good performance on it. The difference though, do you know what a human can do?
I was going to ask.
90%. Human will understand you 90% in a standardized patient setting with a human actor. So that's someone that has somewhat of a...
It's 90%?
With a human, it's 90%. It could be lower if the human's an idiot. But here's the issue.
I don't understand.
Here's the issue, though. Humans give fluent responses. Because when a human doesn't understand you, like you need to take this medicine, this medicine, Peyton, right, is really important. You need to take this rectally 3 times a day and take a phosphosoda before that. You understand, right?
Totally.
Yeah, totally. So he just, yeah, and he has no idea what I'm saying, right? And that's what humans do. They're good at covering up when they don't understand things, and sometimes they don't even realize. You just do it automatically. The problem is, right, if you ask, like for example, I discovered something yesterday in a psychiatric case. Like people ask, do you see a psychiatrist or whatever? And someone asked me to ask, have you been seeing a counselor? There's no word counselor anywhere in the training language data, right? Oh yes, I've been farting a lot, came back. So when these systems fail, and they don't, unlike a human, they fail spectacularly, okay? And that's okay, because what I tell students is that, you know what, these are robots. They're a computer, and sometimes they're not gonna understand you. Ask a slightly different way. Because some people, even when, like I look at a transcript, and they understood them 88% of the time for that particular student, and they said the student didn't understand me, the thing didn't understand me at all. And what they were clued into, no, it really understood you as much as a normal human. It's just when it didn't, it was very obvious. And it's not obvious when a human does it. So that is, that's the difference in how these are perceived. So the bar is very high for these types of interactions. But I think we have some individuals who will get 98, 99, even 100% accurate responses. But I think that with current AI technology, I think it's about 95% as good as you can do. And then remember, if you're doing voice recognition, that screws up a lot too. So mostly I get about 90, 92% with voice recognition. And half of the faults due to the voice recognition system. So, I have a slide for this. Oh yeah, and people learn from doing this. But the game here, right? The game for a medical interview is collect the information that's necessary in the fewest number of questions. That's the game. And then when we did studies, we found that time limiting the users increases the performance of them and increases the performance of natural language understanding probability. People are more focused under a time or number of questions they can ask constraint. So we're building a time limit or a limited number of questions into the interview as an option. So they say, oh, you can only ask 20 interview questions. And by the way, some of the interview questions can get 3-4 information items if it's open-ended. Like, so the ear girl, tell me about your ears, will get like 3-4 items. Rather it says, are you having hearing loss? Is there a discharge in your ear? Is there a sense of fullness in your ear? You can ask all those, but the smart doctor go, and I remember being a medical student, I'm going in and interviewing somebody and got all this stuff and I'm really not sure what's going on, right? And then the doc comes in as supervisor and says, what's going on? Well, I'm here to follow up after my cancer surgery for my colon. I'm like, what? You know? So, sometimes open-ended questions often elicit better responses from patients. Unless your patient's an idiot, then you need to ask a very detailed list of questions. So you could write things where you have a high-functioning patient who can elucidate things, and you have a low-functioning patient who can't, and then you can write the scenarios to force them to ask the detailed questions. And people do that. Some people are just very concrete. So here's the structure of the medical interview here, where there's just lots of topics, but it's pretty shallow. Now we do have follow-up opportunities where they can come back at you with a question, but that's generally part of that design pattern. And when you use these, first of all, you have to use a natural language understanding system. You have to design your encounter. You have to have lots of training language data, and then you need to test it with real humans. Because even you aren't going to think of all the ways to ask. Someone else is going to think of something you never thought of. So the ear girl, who's a 4-year-old case now, someone just yesterday asked something that never went in the system. Even though we anticipated the question in that case. No, it wasn't. It was a psychiatry patient. It was a schizophrenia patient, I think. Even though we had it in there, someone asked it in a new way. Okay. All right. So this is what assessment looks like for the natural language encounter that we use. We have a transcript. We have these tags that are high priority and normal priority. The green ones are high. And we show when they catch them in the transcript. And then we give like general feedback and a learning curve. But what we do here is this is their condition. And you see these blanks. These are the things they didn't get the information. So they can click on this, and it'll show what question they could have asked to have elicited the information, and maybe with a comment from the author. So these are the things that are related to the condition, and these are things that you would rule out other bad things they could have. So you want to make sure they don't have a brain tumor or something else like that that's related to that complaint. That's there. The stuff related to what they have is here. And it's organized by body system. So that's what that feedback looks like. Feedback's really important for these. Otherwise, it's just an encounter and playing. So they need to have feedback and replay in order to learn. And you want them optimally, they'll get most of the learning on the second play, and they'll get some more in the third play. And after 3 plays, they don't learn very much more. They still learn some. And after 4 plays, they don't learn anything. So I wanted to show you that those are the elements. Oh, I made a slide for that. I didn't see that. Oh, well. Okay. So when you game these, you're either trying to reach a certain conversation outcome, collect information, you want responsiveness, and you want constraints, and you want replay value from that. And I want to show you a prototype we're working on with multimodal sensing, where we're not only taking the random access interview, we're adding sensing, multimodal sensing, where the character is looking at you, looking at your eye contact, looking at your facial expressions, analyzing the language you're using, and then judging you every step of the game. And the idea is we're teaching the computer to lie to you or tell you the truth, depending on various parameters. So I think that's the next slide. It's very quiet, the audio level's low, so pay attention carefully. Oh, that's not it. Let me show you, wait, hold that for a minute. Let me show, here's examples of questions people, at the time before we did voice recognition, typed to a computer. That was a study we did in 2015. It's nice to meet you, Anna. What is your name? These are the taxonomy names of our taxonomy in our database, like onset duration, pain duration. Can you describe the pain general? That's an open-ended question. Pain rating scale, can you rate it on a scale of 1 to 10? So those match fine. Here's examples of ones that didn't match. Do you wear earplugs when you swim? We just didn't have that in our, a lot of people asked it, so we added it later to the case. Does anyone else on your team have an ear case? That was very specific. And we eventually matched that to sick contacts item. What do you mean by that? That was kind of general. We didn't know what to do with it, so that wouldn't work. Inside the ear or outside the ear? We don't have that in our taxonomy. Here's one. Do you feel faint? It classified to fainting or syncope from the heart, but they meant lightheaded. So we actually retrained that question to lightheadedness. Now, these are improper questions that people actually typed that there's nothing we can do about because we can't interpret them. An alien? And she said at one point, my brother, yeah, I have a nice family, but my brother's an alien. And then people wanted to type and ask questions about the brother, or someone typed an alien, and there was nothing else. The computer doesn't understand the word an alien. Any pressure? We fix you now. Are the pools clean? Actually, that would be a valid question because she's a swimmer. But it's not in the system. What's your favorite question? Your favorite color? We didn't put favorite color, your hair color. By the way, when he built this multi-million-dollar system, and I showed it to my dad, who always thought I was playing on a computer, and so you just play games. And I showed him, I built this thing with the avatar, and he says, you can ask it questions? Yeah, ask it what her hair color is. Won't do that. He goes, I thought so, and he walked away. I can't please him. So what kind of beer? Anyone around you sick? But the word around is spelled wrong. And because of the spelling error, it mismatched to are you sick? Because it says you sick is, since that's what it saw. So sometimes if a lot of people make a spelling error, we'll train the spelling error into our system. And then any problems with Hernig, and it didn't understand because any problems with associates with a lot of items, but it doesn't know what Hernig is. So it didn't know you're asking about hearing. And then cheating. So some people would just type in words like activities, grades, depression, manic. And that works. We put a cheat detector in where it gets mad at you if you do that too many times, because even though it works, you don't. If there's like 11 items on depression, so you don't know which depression item you're going to get if you do that. So you might be missing a lot of stuff by cheating. And then remember the mailbox person in Zork? We still get that too. So here are some examples in our study where what people took, like New York City, patient is combative. Dang, that's cold. French is a dead language. By the way, people in Montreal got a little upset. I think you're getting fat, and I'm a pretty amazing doctor. Imagine that, a medical student with a big ego. Weirdly enough, a lot of people commented on this patient's weight. Some people said she was too fat, some people said she was too skinny, and she was offended either way. All right, so let's show you the future with the multimodal sensing.
Hello.
What she thinks of him is here. This is a prototype. Good eye contact at symbol.
I'm Dr. Brennan.
What is interpreting visually is here.
It's nice to meet you, Doctor.
How is school?
See, smiley face. He's nice.
It's going pretty well.
How can I help you today?
Well, I heard that contraceptive pills can be used to help with acne. I'm interested in improving my complexion.
So his reaction, he's calm. He's not. So he's got.
Sexually active, have you?
Pops the question. She likes him.
You have to be worried. I thought I could get out of feeling easy. I tell my mother that pill is for my skin.
She got a truthful answer. Pretty cool, huh?
I understand.
So Mr. Nicey Pants here is subject A. Let's look at subject B, the French guy who programmed the system.
Hi there.
He's looking at his cell phone.
Why are you here?
Friendly question.
Well, I heard that contraceptive pills can be used to help with acne.
Now look at his face.
I'm interested in improving my complexion.
What? Now look down here.
Wait, contraceptive pill for acne.
Freak out detected. She doesn't like him.
Are you sexually active?
Not at all. I'm here for my skin.
What do you take for your
And he has no idea until he sees the after action report. She lied to him.
I think proactive.
This happens in real life, by the way. So now he thinks he's just dealing with the skin problem, and he misses the real reason for the visit. And that's multimodal sensing. By the way, the virtual patient with a random access is very difficult to do. What I just showed you is still experimental, and it's extremely difficult to do. Questions? Yes, up there, second row, ma'am.
Oh,
Yes, sir.
Yeah, I'm just looking at the silhouette. Yeah, my question is, this is done with the English language.
Mhm.
How are the synthetic languages or the AI and how do you call it?
It doesn't really care. We have a language translation service we use, but the performance decreases quite a bit.
Okay.
And we can input in 28 languages. By the way, this is available to see on standardpatient.org. And that's a freeware kind of community for medical simulation. So it's standardpatient1word.org. It works with any language theoretically, but here's the catch. We currently use Azure language translation, so you could talk to it in Spanish, for example, and it'll speak back in English, but subtitles will be in Spanish or Russian or whatever. Okay. Now, it doesn't care the language as long as there are words in the language. The problem is that there are 15,000 language training items for 750 topics. In order to port this to a new language, you have to rebuild that. That's the catch. Another question? Yes.
So how well does this scale to lower-end computer systems?
This is made for lower end. This is all done in the cloud, and all the hard thinking. If the computer can play a YouTube video and have a web browser, it works. Because this is designed for like government, military, and VA computers that are often 10 years old. And so we use low bandwidth video clips. So that's why you sometimes see a little stutter in the video. All the thinking's done in the cloud because we don't want to render anything in 3D in anybody's client because these types of users have really bad computers. Very good question. Any other questions? Yes, back there, third row.
Do you think in terms of the voice recognition, the future is more geared towards increasing that 95% correct recognition or increasing the 5% like a more appropriate response even if it's wrong?
Yeah, we miss, it gets the, well, yeah, do you improve voice recognition? The answer is both. You improve voice recognition, improve your interpretation. We actually get a lot of the, like when I speak to it live, it'll get a lot of the voice recognition wrong. And often because certain keywords are present, it matches correctly. But we need to improve both. And I still think that you're still going to have a hard limit of about 4% we'll never get because people just say weird things. And you can't predict everything they'll say. Maybe one day you'll find a way to respond to that, but currently not really. Because the system in the end is kind of dumb. Yes? Any other questions? Yes?
What was the website again?
Standardpatient.org.
Is the natural language processing data that you guys collected available?
No.
No.
No, it's a proprietary system, but I license it. Yeah, come see me later. Anyway, that's all I have for you. Thank you very much for your great questions and attention today. And I'm available up here.